Here we're going to go over several examples of solving literal equations. And literal equations are equations that have multiple variables. And we're just rearranging to solve for one of those variables. So in this case, they're asking us to solve for w, but it's being multiplied by h. We need to remember that h is a variable that is an unknown number, but it is a number. We just don't know what it is. And the same with m. It's a number. We just don't know what it is. So let's come up with an example of an equation and act as though we do know what h and m are. How would we solve this? Easy. We would undo this multiplying by 9 by dividing by 9, because anything divided by itself is 1. What we do on one side, we have to do on the other side, so we're left with 1w equals 2. Now let's use that same process to solve the equation on the left. We're going to undo that multiplying by h by dividing by h, because anything divided by itself is 1. What we do on one side, we have to do on the other side, so we're left with w equals, what is m divided by h? If they were like terms, if they had the same variable, the same exponent, we could combine it. But this is the deal with literal equations. The answers are often very messy. Often you cannot combine like terms because there are so many variables in that equation. M and h are not like terms. We can't combine them. We don't know what m divided by h is, so we just leave it as m divided by h. Let's do another. Here we're asked to solve for m. There's one other variable in there, but we need to basically get it m equals what? We need to move that 4, we need to move that 3n. Let's come up with an equation and act as though we know what n is, that m is our only unknown variable, and think about how we would solve that. Now, if I were solving this example equation on the right, the first thing I would do is to move this minus 2. It's good to always undo what's added or subtracted to the variable before you undo the multiplying or dividing. So I'm going to undo that minus 2 by adding 2, because minus 2 plus 2 is 0. So I'm going to add 2 on the right side as well. So we're left with 4m equals 16. Let's do the same for our equation on the left. Again, we undo this multiplying last. First, we're going to move this minus 3n, and we're going to do that by adding 3n. We need to do that on both sides of the equation. On the left, we have minus 3n plus 3n. That cancels out. If you have something in the positive and the negative, it's always going to be 0. So on the left, we're left with 4m, and on the right, again, 8 and 3n. They're not like terms. We can't combine them. So we just need to leave it as 8 plus 3n. Now let's go back to our other equation on the right. How do we undo this multiplying by 4? Dividing by 4. Not m, 4. Because 4 divided by 4 is 1. We need to divide by 4 on both sides. So we're left with 16 divided by 4, which is 4. Now let's solve the problem on the left. Again, you undo the multiplying by 4 by dividing by 4. Because 4 divided by 4 is 1, we need to divide the right side as well. We're dividing that whole thing by 4. So we're going to divide 8 by 4, and we're going to divide 3 by 4. And so that would be our answer. Now, this one is a little tricky. When you have an equation with parentheses, typically we want to distribute. Let me go over some examples, an example similar to this, but with only one variable here in the same spot, so we can see why distribution isn't going to work. Now, if I were solving this equation down here in blue, I would distribute. This would be 2x and 3x. And because there's just one variable, notice on the right, there are like terms that I can combine. 2x plus 3x is 5x. And then you can divide by 5 and see that x is 2. Let's see if we can do that for this literal equation. If we distribute, we're left with t times r and then 4 times t. Or we can rewrite it just to put the t in the same spot. We have r times t, 4 times t. Now, they both have a t, but we don't know what r is, so we can't combine them. So there's nothing to do from here except factor it back to t times r plus 4. So this method isn't going to work. Another way you could have solved this example problem is just combining your like terms before you distribute. 2 plus 3 is 5. And then if you divide by 5, again, you get x is 2. But does that method work for this problem? No, because we can't combine r plus 4 because we don't know what r is. It's unknown. Now, the way that would work is to just undo this multiplying. Don't worry about combining like terms. Don't worry about distributing. Just think of this as multiplying by 2 plus 3. How do we undo multiplying by 2 plus 3? Dividing by 2 plus 3. Because anything divided by itself is 1. So what we do on one side, we need to do on the other side. So we're left with x equals 10 divided by 2 plus 3, or 10 divided by 5, which again, we get that same answer 2. So this is the method we are going to try. This is the one that is going to work here. So if we look at this, we want to undo multiplying by r plus 4. So we're going to divide by r plus 4. Because anything divided by itself is 1. And we need to divide by r plus 4 on the left side as well. So we're left with t equals 28 divided by r plus 4. Now let's do one more. This one has 3 different variables. We want to solve for a, so I'm just going to come up with an example that has a variable here, but put a number here and here. Let's act as though we know what those 2 numbers are and don't have to use variables. So if I were solving this equation here on the right that just has one variable, remember we have some multiplying, we have some subtracting from the variable. I always undo that subtracting first, so I'm going to add 4 to both sides. So I'm left with 2/5 x equals, because minus 4 plus 4 is 0, and then 8 plus 4 is 12. Let's do that same thing to our problem here on the left. Let's move that minus q by adding q, because minus q plus q is 0. So we're left with 3/4 a equals k and q. Nope, they're not like terms. We can't combine them, so I'm just going to leave it as k plus q. Now, let's think about undoing that fraction. If I want to undo multiplying by a fraction, what I do is I multiply by the reciprocal. So I flip that fraction. That's 5/2. Because if you think of it, 5/2 times 2/5, you just multiply across. This is 10 divided by 10, which is 1. So on the left, I just have 1x. And on the right, I need to multiply that by 5/2 as well. So if I multiply the top, I get 60. The bottom, I get 2. 60 divided by 2 is 30. Now let's use that same process to move the multiplying by 3/4. So we're going to multiply by the reciprocal, 4/3, because that's going to cancel out. And on the right side, we need to multiply by 4/3 as well. So we're left with a equals, now when you have some variables multiplied by a number, a constant, then typically you put that number first. So let's just put the 4/3 in front, and that is being multiplied by k plus q. And that's your answer.